Okay, now we're doing the review for section 3-1, and our first task is to graph an example of some function f of x such that the limit as x goes to 5 of f of x equals 4. Well, we can do that. And so we have some function. Here we are at x equals 5. And our y value is 4. And I'm just going to put an open circle there just because I can. Doesn't matter whether it's open or closed. So 5 and 4 is the ordered pair. And let's see, there we go. And there we go. There's our function. The limit as x goes to 5 is 4. Now, the next part of this question, the final part of this question 1, is graph the limit or a function such that the limit as x goes to 5 of f of x equals d n e does not exist. Well, let's do that. So I'm going to graph it such that at x equals 5 we've got a vertical asymptote, and so as x approaches 5 from below, the f of x tends to go to infinity, and as x approaches 5 from above, f of x tends to go to negative infinity. So there we have it. There's a graph, and it meets this criteria. The limit as x goes to 5 of f of x equals does not. For number 2, we have to find the limit as x goes to 7 of 2x minus 5 over x plus 7. Well, this is very simple. We can just evaluate directly, because if we let x take on the value of 7, the denominator will not go to 0. So we're talking about letting x be 7. So 2 times 7 minus 5 over 7 plus 7, which equals 14 minus 5 over 14, which equals 14 minus 5 is 9, 9 over 14, and we're done. Well, let's do number 3, and I think I'll graph this too to illustrate what's going on. And what we're asked to do is take the limit as x goes to 4 of, in the numerator, 2x minus 4, and in the denominator, x minus 2 quantity squared. And so we're going to have a vertical asymptote at 4. And we're going to have a y-intercept at letting x be 0. And squaring this, I would say we get negative 4 over 16, which is going to be negative 1 over 4. So 0, negative 1/4. And to find the x-intercept, and by the way, we have that vertical asymptote here. To find the x-intercept, we just let the numerator go to 0. And what will take that numerator to 0? Well, you agree it's 2. So we're at 2, 0. Now, the next issue is what's going on as, well, let's, hold on a second. Let's find the horizontal asymptote. And the horizontal asymptote is 0, because the degree of the denominator is greater than the degree of the numerator. But we're going to cross that horizontal asymptote, and we can do that early on The horizontal asymptote will not be crossed as x goes to infinity, but it can be crossed early on. So now, this equals approximately, and the reason I wrote equals approximately, we're going to let x go to 4 in the numerator. And would you agree 2 times 4 is 8 minus 4 is 4? So essentially, when we'll have 4, approximately 4, very close to 4 in the numerator, downstairs we'll still have this x minus 4 squared. Now look, whether we let x be like 3.99, which is close to 4 but below it, the difference would be negative, but when we square a negative we get a positive. Or we let x be like 4.00001. The difference in those two will be positive, and when you square it, it's still positive. The point is this. This denominator, regardless of how close to 4 we get without actually getting there, will always be positive. This is positive. The quotient of two positives is positive. So this thing looks like that. So therefore, the limit equals infinity. As you can see, they're both going towards infinity. On the other hand, does that exist? No, the limit doesn't exist, but they are both going in the same direction, so we'll say that this goes to infinity. But the limit does not exist. Now, if they were going in opposite directions, we couldn't say that. We'd just put down strictly dne. But now I'm going to say the limit goes to infinity. Okay, time for question 4. And it says find the vertical and horizontal asymptotes. Well, let's graph it also. And will you agree there's a vertical asymptote at -7? Okay, so we'll graph that. Will you also agree that there is a y-intercept at -5/7? Or -5/7. And there is a x-intercept, y-intercept at 0, -5/7, x-intercept at, let's see, what'll take this to 0? I would say 5/2 will, correct? You check it out. 5/2 are 2.5. So 5/2, 0. Now we have to find the horizontal asymptote. So we're going to look at the limit as x goes to infinity of 2x minus 5 over x plus 7. So what we're going to do, the degree of the denominator is 1. So that's x to the first. So I'm going to divide every component by x to the first, x to the first, and x to the first. In other words, I'm multiplying by numerator and denominator by 1 over x. Now, this, as x goes to infinity, that's going to go to 0. As x goes to infinity, that's going to go to 0. These divide out and you just get a 1 here. These divide out and you get a 2. 2 over 1 equals 2. And that is the horizontal asymptote. Now if we were to look at the limit as x goes to -infinity, that we would get the same result. So now we have a horizontal asymptote at 2. And there it is, and we can graph the equation. And that's what it's going to look like. But the point is, horizontal asymptote at 2, vertical asymptote at -7.